In this part of physics, we are going to talk about electricity. And the points that we are going to cover in this video in electricity will be conductivity of materials, electroscope, a charge, what is the charge, and what is the relationship between charge in Coulomb and electrons, and also Coulomb's formula and how we apply it for two opposite or similar charges, and also electric field. So as we know that positive with positive charges they repel each other, and negative with negative they repel each other. So similar charges they repel each other, while opposite or different charges they attract each other. So positive with a negative they attract each other, while similar charges they repel each other. Okay, what are the charges? The charges in general are electrons. So if you have a wire here, and inside the wire there are atoms. There are atoms, and these atoms they have electrons, and these electrons they can move. In metals they can move, so metals are called what? Conductors. So what are conductors? Conductors in general are metals that allow electricity to move through the wire. So that means its electrons are movable electrons, they are able to move, so they can conduct what? Electricity. While insulators, they don't allow electrons to move through them, so we call them what? Insulators. They prevent moving electricity through them, and it's hard for electrons to move through them. Okay, now with electricity now and the charges, if we have now two rods in real, when you rub two things together like a pin in your head, when you rub it, that means what will happen? It will be a charge. One of them will be charged positively and one of them what? Negatively. How one of them is charged positively and one of them is charged negatively. For example, now I have this object now, and I have this object. So I have two objects. Normally, by nature, this object contains atoms, and this is an element, and this one is an element. And these atoms that are inside each element, in each atom, number of protons equal number of electrons. So the negative charge equal what? The positive charge. And here the same, the negative equals what? The positive charge. So that means number of protons in an atom equals number of what? Of electrons. And this is for any neutral atoms and elements. Now when they charge each other by rubbing here, what will happen? Some of the electrons of one material will transform to the other one. So that means if electrons now some of the electrons will move from this one into this one here, that means in this case now for this part, number of electrons will be greater than number of what? Of protons. So that means the negative charge will be greater than what? Than the positive charge. While here in this one now, when some of the electrons are moving away from this object, so that means now electrons, which is the negative charge, will become what? Less than protons, which is what? Positive charge. So that means in this case, what do we call this object and what do we call this object? The one that has more protons, we call it positive charge, and here, or positively charged. And the one that has electrons more will be what? Negatively charged. So that means how we say an object is positively or negatively charged, it depends on which ones are more, protons or electrons. If electrons are more in it, more than the protons, that means it is negatively charged. If number of electrons are less than protons, so that means we say here it is positively charged. And we have to remember that electrons are the charges that are moving, not protons. Protons will remain in their places. So electrons, they are the main controllers. When they move away, that means there is here a loss in electrons, so this part will be positive. When electrons come to a material, that means there is increase in the electrons, so this material will become what? Positive. Okay, now if we have in real now two rods, this rod now and this rod now, but we didn't know which one. But here now in the picture, it shows that this one is positive and this one is negative. But in real, we didn't know these rods are positive or negative. So we use a device that is called what? Electroscope. And electroscope is a device that helps us to understand what type of a charge a rod has. You have a rod now. For example, now you have a pen, and you rub the pen on your head. This pen will be charged either negatively or what? Or positively. Now, when it is charged now, how do I know what type of a charge is it charged? Is it positively charged or negatively charged? How I know? This electroscope now will help us then to understand if this one is positively or negatively what? It charged. Okay, what does it contain here now, the electroscope? It contains here like a circle disc of metal, and it has here now, as you see, like a pipe or like a bar of metal as well here, and it has here two thin leaves, and these are very thin leaves, and these leaves now, they are the main sensor. That means they can spread out away of each other, or they can attract themselves together. Okay, now, normally now, before we start anything, we have to know that on this disk now, number of protons equal number of electrons. So that means now this part is neutral. And here in this also, it is what? Neutral, number of electrons equal number of what? Protons. And here on the leaves as well, number of protons equal number of what? Of electrons. So that means for these two leaves now, there is no attraction and also there is no repulsion. So that means they are in their standard position. They are not pulling or attracting each other, because number of protons in them equals number of electrons. So that means none of them is charged positively or negatively. Now, what happens now if I give them now, if we take this one now, this bar which is negative, and we make it what? Closer to the what? To the disk, as you see. How can we explain what happens now? Look, when we move this one towards the disk, as you see, the disk will be transformed into positive, and the leaves down will be changed into what? Negative charge, and they repel each other. So that means they'll move away of each other, so the leaves are opened, are spread out. What happens now? So what happens exactly, as we said, normally this disk now, number of protons equal number of what? Of electrons. Protons equal number of electrons, so that means it's neutral. When we take this rod now near to this disk, this one is negatively charged. So that means it has more number of electrons than number of protons. When it is close to here now, these electrons now, with these electrons that are here, they'll repel each other. They'll what? Repel each other. So that means they'll try to move away of each other. So as the rod is moving towards these electrons now will try what? Will try to move away of this rod. How will they will move? They'll move down. They'll move what? Down. The electrons will move down. When they move down, that means on this disk now, number of electrons will be less than protons. So that means protons is more. So that means this one will be what? Positively charged. Okay, when these electrons now are moving down, as you see, they'll go into the leaves. Then in the leaves now, number of electrons will be greater than number of electrons. So that means these two leaves will be negatively charged. When they are negatively charged, they'll repel each other. So that means these two leaves will be opened and they'll spread away of each other. So we understand now what happens now when we add, as you see, when we move this one now towards that disk, the upper disk, now the electrons of the upper disk will move down. The electrons of their atoms will move down. So as you see, the leaves down will have more electrons. So they'll what? They'll be negatively what? Charged. Okay, what happens in this case now? While these ones now are changed into what? Into negative. When I move to the rod, to the disk exactly, it becomes negative. That means now electrons now are moved from here to here. more electrons moved from the rod into the disk. So this disk now has more electrons, so it's negatively now charged, and here it has what? More electrons, so negatively charged. So that means now the electroscope has in general more number of electrons than number of what? Of protons. So that means now it is negatively charged. But when it was in the beginning here, if we now move it, okay, now if we move it back as it was, look, while we are moving this one towards the disk, as you see, the upper disk now is still positive and the leaves are negative. What does that mean? That means now, till now, no gain or loss of electrons by the disk, the upper disk. That means only what happens now is movement of electrons of the upper disk towards what? Towards the leaves. Then the leaves becomes negatively charged and the disk becomes what? Positively charged. But there is no real what? Gaining or losing of electrons. Okay, if I keep now moving the rod towards the disk now, look what will happen. In this case now, the rod will give the disk electrons, will give it what? Electrons. So in this case now, the disk has more electrons in it, and these electrons, part of them will be transferred down. So now the electroscope has more electrons than protons on its disk and also on its what? Leaves. Okay, now in this case now, for example now, I have an electroscope that is exactly in this case now. I have an electroscope that is on this case, as you see. It has two leaves that are partially what? Opened. Okay, now, and I have a rod here, as you see, and I have a rod here. And for example, I didn't know what type of rod is it. I didn't know is it positive or negative. Now, when I move it to the electroscope, what will happen if it is positive and what will happen if it is negative? And I don't know what charge here for this rod. Okay, we know that these ones now are, as you see, partially open. So now, if I give them now a rod, if I give a rod now towards the electroscope, and this rod has the same charges that the electroscope now already has, in this case, the leaves will be opened more. The leaves will be opened more because they'll gain more electrons, more same charge. But if I give them different rod, like positive, in this case, the charge will be transferred here and the leaves will be what? Closed, and that means they'll be back to their original. So that means if we give them here now, as you see, the leaves will open what? More, will open more. Okay, now what about if I give it positive? As you see, look what will happen now if I give it positive. The leaves will become what? Here now, the leaves will be back to their original. That means they'll be closed again. So when we give this one here, we understand now what will happen when we move this negative rod towards the disk. We said that the negative electrons of the disk will move down. But now what happens if I move this one here? If I move this one now towards the disk, what will happen? What will happen here? Well, the protons, which are negative, will move down. Look what will happen. As you see, what happens here? What happens here? As you see, the top disk becomes negative and the lower leaves becomes positive. How can we explain that? To explain that, we need to understand what happened now. When I move this positive rod to the disk, to the upper disk now, the protons are not moving. But now what happens now, this disk here will be attracted to what? To these protons. So that means the electrons here will be attracted to what? To these protons. So that means it will pull the electrons that are here. The electrons on the leaves will be pulled as well to this disk now. So this disk will be full of electrons in order to be attracted to these protons. So these ones now, when there is loss in their electrons up, so that means these two leaves will be what? Will have more protons than electrons. So in this case, they are positively charged. They are positively charged. So we understand now what happens with the positive and with the negative. So as you see here now, when we move this one now, what happens? As you see, while the leaves are positive because their electrons now are moving up. When they moved up to the disk becomes negative. It has more electrons than protons. So that means in this case, what happened is moving of electrons from the lower part to the upper part. But if I give this one here now, what is moving is the opposite. The electrons of the upper part will move to the lower part, will move to what? To the leaves. So the movement is the movement of electrons. So we understand now how we use the electroscope to understand what the charge of a rod as, whether is it positive or negative, and we understand if it is spread partially, if you add any rod and they open more, so that means they have the same charge. If it is opposite, they have what? Different charge. And we understand what are insulators and what are conductors. We understand that metals like copper, like silver, like gold, like iron, in general, these ones are metals and they are conductors. That means they allow charges, they allow the electrons in their wires to move. So that means they conduct electricity, while insulators like plastic, like ceramics, they prevent the movement of electrons. So that means they are called insulators. Okay, now we'll go to the next point, which is charges. Now we studied here type of charges, but what is the charge? And what is the unit of a charge? And what is the relationship between charge and electrons? We'll explain it in this point. So in this part now, as we know, any wire here, this one is a wire like wire of copper here or silver. This wire, it has atoms inside it, and these atoms contain, each atom, as we know, it has here protons and neutrons in the nucleus, and it has what? Electrons that are moving what? Around the nucleus. And protons and neutrons are usually inside the nucleus, and they are not movable. They stay in their places, while electrons, they are movable. So electrons, they can move. So for this wire now of silver, for example, these electrons that are around these ones here, they can move. So that means when we give now just potential difference from the station of electricity to this wire now, these electrons, they will what? They will move. When they move now, this movement of electrons, this is the electricity. So when it is moving electrons through a conductor. So when these electrons, then when they go to a bulb, it will make it in another way. We'll explain it later. It will change it into what? Into light. So these electrons now, number of electrons that are moving in a conductor by 1 second. By 1 second is called electric current. So electric current are number of charges that are moving through a conductor in 1 second. Okay, these electrons now, can they be counted? Can we count them 1 electron, 2 electrons, 3 electrons, 4 electrons to get how many electrons are moving there? Okay, when we charge our mobiles, what do we do? When we charge batteries or mobiles, what do we do? We are moving electrons from the electricity into our mobiles. That's what was happening. So it charges, when we charge it, that means you are giving it charges. What are these charges? Are electrons. Okay, do we count? Or can we predict how many electrons we can predict our mobiles in one time? How many electrons they can move? Okay, this is what we need to understand now. And what unit is it? Okay, so as we said, the wires now, what is moving in it is what? Is electrons, and electrons are negative. Okay, millions and trillions and quadrillions and quintillions, by the way, these ones even more, billions of electrons when they move just to charge your mobile. That means we need billion of a billion of electrons to charge your mobile and more. So these electrons, can we count them? Okay, can we write this number? It's too huge. So in this case now, scientists in physics created that. We'll make one unit that summarize number of electrons, and we call it what? Coulomb. So that means now the unit of a charge is Coulomb. But 1 Coulomb, it means number of electrons. How many electrons are there in 1 Coulomb? It's going to be about 6.25 times 10 to the power of 18 electrons. You imagine this number now. It is 6 and 2, 5, and also here 16 zeros. So that means it's 6.25 billion of a billion electrons. Billion of a billion electrons. This number now of electrons is called 1 Coulomb. Is called 1 Coulomb. So that means if this number now of electrons are moved from the electricity into your mobile, we say that your mobile now is charged by 1 Coulomb. By 1 Coulomb. Okay, this now huge number of electrons, as we said, in 1 Coulomb. Okay, that means 2 coulombs. That means it will be twice this number of electrons. 3 times. Okay, now how many coulombs do our mobiles need in general or as average? Our mobiles usually need about 10,000 or 11,000 coulombs, you see, of charges in order to be charged. Around 10,000 what? Coulomb. And each Coulomb, it contains this number of electrons. You imagine? It's a huge number of electrons. That means now you can imagine the size of an electron. How is it? So that means 10,000, you multiply it by this number, you're gonna get, as you see, a trillion of a billion of electrons. Like this, it's gonna be around that number of electrons that your mobile need to be charged for 1 time only. Okay, this one here now, what we need just as a summary to understand from this point, that 1 Coulomb equals 6.25 times 10 to the power of 18 electrons. So instead of using, by the way, we can use electron as a unit of a charge. But since it is very small and we'll need big numbers to explain the charge, so in this case, we created that 1 Coulomb that equals this number of electrons and to be used as a unit of a charge instead of what? Of electrons. But now, 1 electron now, as you see, 1 Coulomb equals 6.25 times 10 to the power of 18 electrons. Okay, 1 electron now equals how many coulombs? We need to divide here by what? We divide by 6.25 times 10 to the power of what? Of 18, and we divide here by 6.25 times 10 to the power of what? Of 18, in order to get what? To get, so this part now will go by this part. So what will you get then? You'll get that the electron equals 1 divided by 6.25 times 10 to the power of 18. It's gonna be 1.6 if you divide it times 10 to the power of what? Of negative 19 Coulomb. So that means now the charge of 1 electron, it came as a result of dividing 1 Coulomb by number of electrons in 1 Coulomb, and we get 1.6 times 10 to the power of negative 19 Coulomb, and this is now the charge of an electron in coulombs. So the charge of 1 Coulomb in electrons is going to be 6.25 times 10 to the power of 18 electrons, and the charge of electron in Coulomb, it equals 1.6 times 10 to the power of negative 19 Coulomb. And since the electron is negative, so you put here what? Negative for the electron. So you understand now what is the charge of electron and what is the charge or how many electrons in 1 Coulomb. Okay, what is important now to know is the charge always is number of electrons. So if it is 1 electron, so this is the charge. If you charged something by 1 electron, that means the charge will become negative 1.6 times 10 to the power of negative 19 Coulomb. Okay, can the charge be 1 electron and a half? No. The charge is only number of electrons. So that means if you charge it by 1 electron, the charge will be 1.6 times 10 to the power of negative. Okay, if it is 2 electrons, you multiply this number by 2. If it is 3 electrons, you multiply this number by 3. So that means, can a charge be 2 times 10 to the power of negative 19 Coulomb? Can any charge be this number? No. Why? Because this number now is not a multiple of this number. So this number now has to be multiplied by integers, by 1, by 2, by 3, and it will not give you 2 times 10 to the power of negative what? 19. That means if there is one electron, this is its charge. If there are 2 electrons, you're going to multiply this one by 2. When you multiply it by 2, it's going to be what? 3.2 times 10 to the power of negative what? 19. Okay, if you multiply it by 3, it's going to be what? Also multiply by 3, by 4, by 10. If you multiply it by 10 electrons, it's going to be what? 16 or 1.6 times 10 to the power of negative what? 18. Or it's going to be 16 times 10 to the power of negative what? 19. So this one now, it can be charged. Why? It can be an amount of charge because it is multiple of what? Of this number. So that means the charge of any object is a number or an integer multiplied by the charge of an electron. So you understand now the relationship between Coulomb and electron, and what does one Coulomb mean, and when do we use electrons and coulombs. Okay, this is now for the second point of this topic in physics. Okay, what is now the third point? The third point, if I have here positive charge, and here I have what? For example, negative charge. And I explained when is it positive charge and when it is negative charge. These charges now, what will happen between them? Attraction. That means they will attract each other. And when they attract each other, that means there is force of attraction. There is force of attraction. How do I know this amount of force between them? Okay, as we know, the Newton's law of universal gravitation. He said any two objects in the universe, like the Earth and the Sun, like any other two objects in the planet, there is a force between them of attraction. And he said that the force equals the G, which is a constant, times the mass of the first one times the mass of the second one, divided by the radius between them, or the distance between them square. This is now Newton's law for universal gravitation. This law now, when it is applied here for the positive and for the negative, we'll get that there is attraction force between them. What is the amount of attraction force now? The attraction force between them equals constant, which is Coulomb's constant, which is 9 times 10 to the power of 9, times the charge. This one, for example, the charge number 1, and here this one is charge number 2, times the amount of the charge number 1 in Coulomb, times the charge of number 2 in Coulomb, over the distance between them squared. So that means now to find the force of attraction as a number between any two charged objects, we do this formula. Okay, what about if it is positive? Negative and negative charges. These negative and negative charges, what the force between them is repulsion. So they repel each other. When they repel each other, what is the amount of force of repulsion? How high or how strong they repel each other, how weak they repel each other? We find this force of repulsion by using what? This formula. Constant times charge of object 1 times the charge of object 2 divided by the radius, which is the distance between them squared. Okay, now what is electric? And we have many questions to apply it here. So that means if we have the charge here is 1 Coulomb and here 1 Coulomb and this constant is 9, so and here the radius is 1 squared, so that means the force between two charges and each one of them is 1 Coulomb, it's going to be and the distance between them is 1 meter, so that means it's going to be around the same K, which is 9 times 10 to the power of 9. We have many examples then to apply this formula on. Okay, now what is electric field? Which is the last point now we are talking about, electric field. Electric field is, you can see here, if there is here a positive charge and here a negative charge, and the negative charge, it will affect the positive charge by a force. This force now, if you divide it by the charge of this electron, you will get the electric field strength on this charge. That means electric field strength, it equals the force, and we understand what is the force. We already finished its formula. The force over what? Over the same charge. Now, if we rewrite this formula, electric field strength. That means it's going to be E equals F. What is F? F, as we said, it's going to be constant times Q1 times Q2 over the radius squared. Now over what? Over this Q. That is here. Over this Q. Now when this Q here goes up here as math, this Q will go by this Q. So that means E will become what? K times just 1Q over what? The radius squared. So this one is the electric field strength. So what is the electric field? Electric field here, if I have positive charge, the area around the positive charge, here the area around it, where if I put negative or positive charge, it's gonna be affected by this by this field. So here the area around a charge is called what? Electric field. Its strength is given by this formula or by using what? This formula. And this is the link between the force of attraction or repulsion and the electric field. And you have now questions that are related. We're going to explain them on the quiz.